So with the reversibility of light, just as I was saying, if light moves from medium A or path A to path B to this path, path C, through this original path, then we are saying that under reversibility of light, when light would have to, when there's would have to be a return journey to from C to A, it will pass through the same original path, but this one in the different direction or in an opposite direction, but it will still use the original path, which is this path from here to here to here. Now, when light decide to move from beneath this medium to this point, then it will still use the same route to that point. So that is what we term as reversibility of light. So we are trying to say that the refractive index of light traveling from one medium to medium 2 should be equal to the reciprocal, or should be equal to 1 all over light traveling from medium 2 to medium 1. That is basically what it means. So if the observer is seeing the light through this angle to this point, then that means the fish, if the fish also want to see the what do you call it, the observer, then the fish will also see through the return journey or through the original, the same path, but in the opposite direction, but it will pass through the same path. And so the fish will also, from the fish will it will use this angle and get refracted here. Here too, it will use this and get refracted in the distance. So basically it's the same thing. And so that is it. Let's try this question. For example, if the refractive index of light from glass to water is 0.8, then the refractive index from water to glass is, and so if the refractive index of water, so the question, this is what you write, from water to glass is equal to 8, 0.8, equal to 0.8, then gravity, then light traveling from glass to water will be equal to, now will be reversibility of light, will be equal to 1 all over 0. So that will give us what? What are you getting? Those with the calculators. That will be 1.25. Yes. So that's what we term as reversibility of light. I hope I made myself clear. So here, if you want to use medium, so this one, if you want to use this 3 medium, then let's see. So this will be light traveling from medium A to medium C. Oh, from medium A to medium C. Why is it the machine is messing up today? I just want to teach you something before we go on. From here, we'll do what we call it critical angle. I'm going to take you to total internal reflection. I'm going to do that. So if today this thing is this worry me. Forgive me, today the screen is disturbing me. So if light is traveling from medium A to medium C, so light moving from medium A to medium C, then that will be equal to the product of number one, light moving from, because before you get to medium C, it will have to move from move from medium A to medium B. I hope you understand. You bear with me looking at the diagram. To medium B. Then when it get to medium B, light will have to move from, that will be the light will also have to move from medium B. Light will have to also move from medium B to medium. So it will have to move from medium B to medium C. So that will be our distance. So light moving from A to C, then we'll have to pass through medium A to medium B times moving from medium B to medium C. That is one thing you can also use. So I don't really realize that A to C, but you would have to move from B to B. So this will be the B. So from B, then from B to C. That is this you can also write using this diagram. Let's we consider three diagrams. So A to B to C, and that is it. So if you want to do the reverse of C to A, then you should know the distance. The only thing you will do, that will be 1 all over the whole of this, and that will give you your answer. Now let's do something we call so that is it. But in terms of refractive index, when we are using angles too, we are going to say if we are considering medium A and medium B, and we are saying that refractive index 1 is this 1 is equal to the refractive index in medium 1. That would have to do with the sine 1, and this one will be the refractive index medium 2. Then we can say that sine what do you call it? Refractive index of medium 1 sine, where sine I is the angle of incidence in medium 1. Should be equal to sine R. Sine R. So that is it. Now we have to do critical angle where R is the refractive index in. So the angle of refraction in medium 2, and I is angle of incidence in medium 1. Now let's do critical angle. Can I clean the board? When you're done, let me know. I want to clean the board.
So please explain the first formula you gave.
Which first formula? This one. Is that this formula? Or this one?
No.
This one?
No, sir.
Is it this one?
Yes, yes.
This?
Yes.
This? Is it this one?
No.
This one?
The first formula you gave under reversibility of light.
Is it this one?
Yes, sir.
So under reversibility of light, we are trying to say that if light is moving from medium 1 to medium 2, it is equal to what do you call it? According to reversibility of light, it is equal to the reciprocal of light moving from medium 2 to medium 1. That is what it means. So 1 all over this. So it's more or less like if light is moving from here to here, then you are given 0.8. That's what we did. You are given 0.8. Then when they tell you that, okay, then now find for the refractive index of light moving from glass to water, given 0.8. The only thing you do is, because it's reversal, you just have to reverse it. But this time you do it 1 all over, what do you call it, 0.8. And so it's just simple, explains the fact that when you move from here to here, under reversibility of light, then when you want to move from B to A, you still use the same path. But this time in the opposite direction. That is how come we have that in the reciprocal. The reciprocal means that when you're moving from 1 to 2, it is equal to moving from 2 to 1, but in the opposite direction. But it will pass through the same path. Do you get it?
Yes, sir.
Good. When you're done, tell me so that I clean the board.
Index of medium 2 is equal to 1 all over refractive index of medium 1.
Yeah, so this means that the refractive index of light moving from medium 1 to medium 2 is equal to 1 all over the refractive index of light moving from medium 2 to medium 1. So this means that the refractive index of medium 1 moving to medium 2. Light moving from medium 1 to medium 2.
Medium 1 and 2.
So in this case, this will be medium 1 and this will be medium 2. So the refractive index of the light moving from this medium to this medium is 1 to 2. That's it. And it is equal to the light now moving from 2 to 1, which is the reversal of the first one. Hold on. Yeah, evening. Patrick, right? Yeah, that's what I'm saying. Oh, Charlie, around. Sorry, so that is it. Let's do critical angle. Critical angle. Now it's still under refraction of light. And so, for instance, when I have let me still use this diagram. So if I have this is my normal. Now when light is moving from medium A, from air into water, from air into water, you know, it will bend away from, what do you call it, sorry, when light is moving from water into air, light is moving from water into air. Now before critical angle must occur, light should move from a denser medium to a less dense medium. Do you get it? Before critical angle will occur, light should move from a denser medium to a less dense medium. In this case, I just trying to say that light should either move from water to air, but light shouldn't move from air to water because water is denser than air. Are you getting it? So before critical angle, okay, light must move from a denser medium to a less dense medium. So in this case, we can see that this medium is water and this medium is air. Now what happens is that when light moves from a denser medium to a less dense medium, I taught you that the light ray bends away from the normal. According to refraction of light, the light ray bends away from the normal. So this, it will bend away from the normal. Now you bear with me that from here to here is the angle of, from here to here is the angle of incidence, and from here to here will now become the angle of refraction. But light bends away from the normal because it is moved from a denser medium to a less denser medium. Now you also bear with me that the more we this thing, what do you call it? The more the more we increase the angle here, the more we increase the angle here. That means now if light is to, if you have to widen up the angle between the angle of reflect, you have to widen up the angle of the angle of incidence here, then the refracted angle will also keep on moving away from the normal. Do you agree with me? Do you agree with me?
Yes, sir.
Now, if we, the more we do it, the more we widen up the same angle. I'm supposed to draw many diagram, but I just want to use just one diagram to do everything. The machine is misbehaving today, but I don't know. When we widen up, you realize that it will get to a certain point whereby the angle of refraction will now, it will move and now be flat with the refracting boundary. Do you get what I'm trying to do? You agree? It will be flat with the refractive in the boundary.
Yes, sir.
Now, when it becomes flat with the refractive refracting boundary, then you are trying to say that this one becomes, it forms an angle of 90 degrees. Do you agree? It will form an angle of 90 degrees here. So now it will form an angle of 90 degrees here. Please, do you agree?
Yes, sir.
PSA, do you also agree?
Yes, sir.
So we define critical angle. When that happens, we are saying that critical angle is the angle of incidence. So the angle of incidence, that will be the angle from here to here. That will be the angle from here to here, for which the angle of refraction in this, the angle of refraction is 90 degrees. It's what we call the critical angle, and it is denoted by C. And so you are saying that the angle of incidence in the denser medium, so the angle of incidence in this denser medium, for which the angle of refraction in the less dense medium is 90 degrees, is what we call critical angle. So the angle for which the angle of, what do you call it, the angle in the less dense medium is 90 degrees is what we call refractive index. So we can define critical angle. So the critical angle is this angle here, the angle that has made the refracting angle to be 90 degrees or to be equal to 90 degrees is what we term as critical angle. Do you please understand?
Please repeat the definition.
The definition says that the angle of incidence, the critical angle is the angle of incidence in the denser medium for which the angle of refracting, what do you call it, the angle of refraction in the less dense medium is 90 degrees. So the angle of incidence in the denser medium for which the angle of refraction in the less dense medium is 90 degrees. Do you understand? So because the angle that this angle here, you realize that had the effect on the angle of refraction. Without this angle, there won't be the angle of refraction being equal to 90. So we define critical angle of as the angle of incidence in this denser medium, because we believe that this medium is dense and the medium here is less dense, for which the angle of refraction in the second medium or in the less dense medium is 90 degrees. Please, do you agree with me?
Yes, sir.
Great. So now you bear with me that if I decide to still increase the angle of incidence, for which this one is 90, when I increase it, this one will now move from the second medium and will reflect back into air, because this will move again. Do you agree? So if I increase this one, the length here, what they call the angle here again, now this one will now move from the 90 degrees and now enter into the first medium again. We'll move into the first medium again. Please, do you also agree with this one?
Yes, sir.
Now, when that happens, we are saying that there's total internal reflection. Now, it has been, now the angle of incidence is greater than 90 degrees. Sorry, the critical angle is greater than 90 degrees. And so at the end of the day, there's total internal reflection. That means instead of an anomalous instead of if you hit this, instead of it refracting, because of the angle at which the incident is at, it has totally internally reflected. And so it has now moved in the second medium and now come up in the first medium again, because of the increment in what they call the angle of incidence. Please, have I made myself clear?
Please repeat what you said.
I said that now it has totally internally reflected in the sense that when the angle of incidence was increased, we had what we call the critical angle, where the angle where what they call it, we had the angle of refraction being equal to 90. Now when we increase the distance, the angle of incidence again, now this angle, instead of it being in the second medium, now shifted into the first medium again. And so here you realize that it has totally internally reflected. So there's like more or less like a reflection. It hits here and it has reflected internally. So when this happens, we call it total internal reflection. And I'm going to give you the definition of total internal reflection. But before that, let us look for the relationship between critical angle and refractive index. Critical angle and refractive index. And so I've already told you that the critical angle is the angle of incidence in the denser medium. The angle of incidence in the denser medium, for which the angle of refraction in the less dense medium is equal to 90 degrees. It's equal to 90 degrees. I hope you get to this point.
No.
You said no.
Please, I did not hear what you said.
I said the angle of refraction, the critical angle, I've already explained it. As the angle of incidence in the denser medium, for which the angle of refraction in the less dense medium is 90 degrees, and I've already explained it. And I said that now, if you want to increase the angle of incidence here again, now what it will do is it will move from the 90 degrees and enter into the first medium again. And now when that happens, we call it total internal reflection. It has now totally internally reflected, or there has been reflection. Reflection has gone on than refraction. Are you getting it? And I said now let's look out for the relationship between total internal reflection, refractive index and critical angle. And so we are looking at the relationship between, when the line cuts, you join again, a relationship between total internal critical angle, which is given by C, critical angle, and refractive index. Now, the relationship between this is refractive index is equal to 1 all over sine C. Refractive index is equal to 1 all over sine C. Refractive index is equal to 1 all over sine C. With a critical angle, if this is here, I'm coming. If this is here, I'm going to get an angle of the 90 degrees here too. So here too will be 90 degrees. And definitely in the second medium will be, the first medium will be 90 here too. 90 degrees in the first medium. That is it. Now, it is given by refractive index is equal to 1 all over sine C. That's the relationship between critical angle and refractive index. Critical angle, refractive index is equal to 1 all over critical angle, sine 1 all over the sine of critical angle. And so refractive index is equal to 1 all over sine C. It's equal to 1 all over sine C. When it is